This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is example 3, finding the tangent of a sum. So we're going to do this one. Find the tangent of a plus b if a is in quadrant 4 with the cosine of a equals 3/5 and b is in quadrant 3 with the sine of b equaling negative 24/25. All right, so we know for the tangent of the sum, we need to find the tangent of each of the angles because of the formula. So keep in mind the formula for the tangent of a plus b is equal to the tangent of a plus the tangent of b all over 1 minus the tangent of a times the tangent of b. So we aren't given the tangent of a or the tangent of b, but we are given some information about their angles. So for angle A, there are different ways to find the tangent of that. I like to just draw the picture. That's easier for me. So I'm going to draw a picture of angle A. It's in quadrant 4. So I know it's over here in this 4th quadrant over here. And the cosine is 3/5. So I could draw that picture of this is 3 and that is 5. And here's my angle A. And I could just draw A here even though you could think of A as going around. It really doesn't matter. The picture still will help you get the tangent. This is going down, so this is 4 spaces. I like to put -4, so I keep in mind that's what the y value is. So these are really just my x and y values and my radius. So I can see from this picture that the tangent of A would be -4/3. Right, I want to do the same thing for angle B. Angle B is in quadrant 3. Okay, so I got to draw it over here. And the sign is -24/25. So I know in the B direction it's going to be pretty long here. So I'm going to put it way down like that. I know it's like that's it's -24. That's the y value. And this is 25. Now you could use the Pythagorean theorem to figure out what this x value is by doing x squared plus 24 squared equals 25 squared. All right, so I'm going to do that on another page. X squared plus 24 squared equals 25 squared. Even though it's -24, when you square it, it's the same thing, right? So you have to do 24 times 24, and that is 576. And 25 times 25 is 625. And so if you just subtract 576 from both sides, you end up with x squared is 49, so x is plus or minus 7. So let's go back to that picture. It's going to the left, so I'm going to say that x value is -7. So that is my angle B. Now, of course, remember B is really all the way over here, right? A, you could think of it going all the way around, or maybe A is just down this way, it doesn't matter. But B is really that whole angle, right? Okay. So, what is the tangent of B from this picture? It's -24 over -7, which is 24/7. So before we could use this formula, we have to figure out the tangent of A and the tangent of B. And this is not the only way you could do it, but this is one way you could figure it out. Okay, so now, let's plug in those values. So we want the tangent of A. So I'm going to do -4/3 plus the tangent of B, which is 24/7 all over 1 minus the product of those two numbers, -4/3 times 24/27. It's not 27ths, it's just sevenths. Okay, sorry. Guess my picture got a little confusing here. I wasn't looking at it very carefully. I'm going to do that again. Okay, so now we have to simplify this. So you could look at it and decide the least common denominator. Now you can cancel this 3 into the 24, but notice you're still going to have to, the least common denominator, the numerators, is still going to be 3 times 7. So I'm just going to leave everything as is and multiply the numerator and denominator by 21. This is all arithmetic at this point. And of course, arithmetic I think is harder than trig for most people. In other words, they're okay getting this, and that's the simplifying that they have trouble with, which has nothing to do with trig. It's working with complex fractions and numbers and etc. So we're going to just distribute our 21 to each term in the numerator and denominator. So let's go down a little bit to do that. All right, so when I have 21 times negative 4/3, I'm just going to show all these steps. 21 times negative 4/3 plus 21 times 24/7, and then 21 times 1 minus 21 times negative 4/3 times 24/7. All right, so what could we cancel? The 3 goes into the 21/7. The 7 goes in the 21/3. Nothing cancels for this first term. And the denominator here, 3 times 7, is going to cancel with that 21. So what do we have? For our numerator, we've got 7 times negative 4, right? 7 times negative 4, that's negative 28, plus, and then we have 3 times 24, that's 72. Denominator, right? So you can see where this is coming from. It gets kind of messy, that's why you got to be really careful. 21 times 1 is just 21. Now what do we have here? We have a minus sign and a negative. That's going to be a plus. And so that'll change those to plus and plus if you want. And then I have 4 times 24, that's 96. So what's that finally going to equal? No canceling. Add the numerators and denominators, right? So let's see. 78 minus, I'll do my arithmetic over here. 72. 72 minus 28, that's 4, that's 44. So this numerator is 44. And then I got 21 plus 96, 117. And that does not cancel because 44, the only factors are 2 times 2 times 11, and that none of those numbers go into 117. So that is our answer. We ended up with a positive 44 1/17. Now let's look at those angles and see if this makes some sense. All right, here were our two original angles. So if I draw angle A first, I could think of that as a negative angle. So here it is in the plane. So here is negative A, and it's somewhere around here. And then I'm going to add that angle. So that looks like, it's more than 180 degrees, but not up to 270. So it's like going more than that. It's going like all the way around. It looks like it's ending somewhere up here. So it looks like it's somewhere here. And this is just a very approximation here. First of all, the tangent is going to be positive in that quadrant. And then I don't know exactly how far this is, but does it look like the smaller number is the y value? And it does. So this seems like a reasonable answer. You're not always going to be able to tell for sure by doing this because there's a lot of guesswork in how you're drawing the little angle since it's not exact, but we're just trying to get a ballpark to see if it seems maybe that's reasonable. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.